Plant breeding, a profession that blends science and creative problem solving to tackle a variety of serious issues that face both growers and consumers worldwide. The basics of plant breeding are simple. A cross is made between two parent plants, and the offspring are evaluated over multiple generations. The goal is to select a variety that is better than the ones you began with. Of course, in practice, plant breeding is more complicated. It requires careful analysis of data that breeders have collected from multiple generations and locations. It takes a trained eye to recognize the combination of traits needed to improve each plant. Even the earliest growers practice selection by saving seeds from their best plants. This resulted in domesticated plants that produced more than their wild relatives and were manageable in a field. Throughout history, farmers have continued to improve these landraces with selection, growing lines more suitable to their local conditions. The modern plant breeder still works from these essential foundations. But today, their program is enhanced by genetics, statistics, and a variety of scientific tools during the selection process.
Plant breeding is the whole world of knowing how to investigate a problem.
It's an art and science of improving crops for farmers.
Making seeds better for farmers to plant so that they can handle the rest of it.
It's a way that you can improve those crops so that you can keep growing them and keep increasing yields.
A plant breeder is an applied scientist. Plant breeding is the art and the science of developing new lines or new varieties that will offer something new to the consumers and the growers.
So when you get right down to it, plant breeding basically means plant improvement. Breeders are looking for new varieties that will improve on what farmers are already growing.
Making a cross between two contrasting parents, you have this idea that if you make the cross, you can develop something unique.
We'll make crosses between two different parents. Each parent often contributes something to the progeny, and that process takes a number of generations because, of course, the sons and the daughters in the first generation aren't necessarily going to have the ideal combinations, but maybe their children or grandchildren have those combination of genes. For example, in this case, one parent has disease resistance, the other parent has genes for other good traits like color. And then we hope that in the progeny, those traits, the resistance and the good horticulture quality, are combined in the progeny.
We literally make hundreds of crosses every year, and we grow out thousands and thousands of plants. So the unique recombinations that we're talking about are fairly rare.
As a plant breeder, we throw away 99.9% of what we do to find that one variety, that one plant, that's going to be an improvement over everything else we looked at.
All these varieties are developed through crossing between two parents, two contrasting parents, and we go through 8 to 10 generations of selection to find the best ones, the ones that are the best yielding, most disease resistant, the most suitable for farmers, and the ones with the best quality.
Here is a good example of things that we are trying to select for and things that we're trying to select against. And this is the case of plant architecture. On this side, you can see plants that are totally lodged on the ground. It's a problem with your architecture, the way the branches and the stems are designed in this plant that are not doing a good job. Versus this one here, as you can tell, we have a strong stem that it's being able to support all that weight from not only from the pods and the seeds, but the plants itself, the leaves and many other things. And even, with some of the wind that we have, or even strong winds, they're gonna hold up to that upright nature, like a little tree. And that's what we want for, that's what we're looking for in the case of upright dry beans, so they can be harvested in an easier way, more efficient way.
Cross, evaluate, select. This process can take almost a decade of data-heavy work to find the needle in the haystack. Admittedly, this process might seem tedious, but breeders stay motivated by the opportunity to positively impact the global community with new varieties.
The end goal should always be helping other people and getting food to where it needs to be.
We want to be paid for our work. It's expensive work to do, but at the same time, we want to make sure that the ultimate benefactor of what we do is the consumer, and maybe that consumer might be in third world countries. I hope it is, so we help with the starvation that's going on.
If you're from a country with a strong farming industry, you might not realize that in parts of the world, food is precious and scarce due to marginal farmland and distribution problems. The crop varieties grown in these countries suffer from the effects of environmental stresses, such as heat or drought. Yield from these varieties is also reduced because of pests and disease damage. When the yields suffer, these countries won't have enough food to sustain their people. Improving the genetic performance of these crops is an important step to reducing food shortages. And this job of improving the genetic performance of plants falls into the hands of plant breeders.
Plant breeding is all about making the best product to feed people, but nobody ever sees what I do, and that's okay. I like to be hidden out in the cornfield and step behind everything else, because it all comes down in the end to what the farmer does. So my job is to make sure they have the right products, the right seeds to plant.
We want to make sure that people have a safe food supply, and then we want to make sure that that food supply is secure.
I look for things that are constant, so that in a year where you have stress, you're still going to have a crop. And you don't necessarily need all of the inputs, but if you do have the inputs, the fertilizer, the chemicals, and the great weather and plenty of water, you're going to have a yield bump.
And so if we're making improvements to our germplasm, we want to make sure that we can distribute it in a way that's fair for the people that use it, that we get paid for our work, which also is fair, but not to the point where we stymie progress in the future. And I challenge future breeders to figure out how they can do that. You know, to develop crops, improve crops, you know, that they make a living at it, and then able to share that with other breeders, you know, so we can take the greed out of our business and get it back and be focused on production.
Many breeders are initiating programs that address the serious issues related to crop production and food stability throughout the world. When farmers can depend on crops, despite pests and diseases, weather or regional variables, food stability becomes viable. Sometimes the path to change begins with the ambition of one individual. The story of Norman Borlaug, a wheat breeder, is a great example. His story is the kind that will stay with you once you hear it. Borlaug was personally interested in arresting global hunger around the 1940s. He won the Nobel Prize, and his work sparked a revolution worldwide. By the end of his career, Borlaug was credited with saving over 1 billion lives through his work in plant breeding. Borlaug moved to Mexico to help farmers improve their crops and increase their yields. When Borlaug arrived, he found disease destroying the wheat crop. The soil was exhausted and depleted of nutrients. Yields were low, and farmers were having trouble feeding their families. The farmers in Mexico were skeptical about experimental crops. The last attempt to improve local crops had done more harm than good. When Borlaug came and tried to explain his vision in broken Spanish, they looked at him like he was crazy. Borlaug could not rest until he found a solution to the problem. Before the sun rose each morning, he was already out in the fields, searching for a way to overcome the stem rust epidemic that was destroying the crops. These blisters crippled the plants, often killing them. Borlaug's team increased yields by changing the production system and introducing wheat varieties that would resist the diseases. They accomplished this after only 3 short years. What seemed impossible only 15 years earlier became a reality when in 1956 Mexico became self-sufficient in wheat production. In 1963, they had enough grain to export and help supply the rest of the world. This coordinated breeding effort affected more than just Mexico. Borlaug expanded his vision and program to India and Pakistan, drastically increasing their food production systems as well. Borlaug's work was a symbol of the importance of agriculture in the global community. In 1970, he was awarded the Nobel Peace Prize for his efforts. While handing Borlaug the prize, the committee chairman said, "More than any other single person of his age, he has helped to provide bread for a hungry world." Norman Borlaug translated his vision directly into action. Through his knowledge and skill in plant breeding, he left the world a better place than he found it. But that's not all. Norman Borlaug is also remembered for his ability to think outside of the box. As a creative problem solver, Borlaug pioneered the method of shuttle breeding. Shuttle breeding was a novel idea that expedited the breeding process and is still used by plant breeders today.
Shuttle breeding is a technique that's advantageous because you can do 2 generations a year. So every 6 months we send the material back and forth. And that gives us double the progress that you normally have in the US, where you only plant once a year. And it also ensures adaptation over a broad geographic area, because Puerto Rico, as you can see, is very different from the States. So for example, we have a shuttle breeding program for drought stress specifically that takes place between Nebraska and Puerto Rico. So in the summer in Nebraska, Carlos Urea plants these same varieties and selects ones that are resistant to drought under his conditions. And then he sends those selections, the best of the population, to me, and I plant them here in Puerto Rico, in the south of Puerto Rico where there's drought in the wintertime, and do the same selection there. So they can be selections of individual plants or of whole plots or families. And over the generations then we see an improvement in drought tolerance. And in the end we'll release a germplasm or variety for use by other breeders or by farmers. I think the key in my experience has been that collaboration, because one person can't accomplish a whole lot alone, but in a group you can accomplish great things.
A lot of collaboration happens in the field of plant breeding. Breeders usually work with a team of people who help them manage their fields and gather their data. They also work with other scientists who specialize in tools like molecular markers that can help breeders identify crucial genes along the way. One example of this collaboration happens in the lab of Consuelo Estevez de Jensen, where she studies plant diseases and uses advanced technologies to make new discoveries.
I often work with different specialists, with different scientists. Plant breeders are one of the most important collaborators that I have because they are testing, evaluating new cultivars of different crops to increase crop production for food security, that I have to know all the diversity of cultivars that they have, all the characteristics, all the genetics of those cultivars, and then I can work with them and do different evaluations. There is a lot of new techniques that we have to apply, molecular techniques. So that's something fun about being a plant pathologist, that you are always learning.
Learning is important for breeders as well. Collaborating with specialists, using advanced technologies, and making new discoveries in the field requires breeders to grow as quickly as their plants.
You know, everything's a tool, and you can pick the tools that you want to use. And as you learn more, you can use more tools. But it's taking the best ideas from everybody that I've met in my 30 years of doing this and applying those methods to get where we want to go.
So I will take every opportunity I can to learn from the people around me.
The public is interested in learning about the methods and tools used within the field of plant breeding as well. People are curious, how are plant breeders developing these new varieties?
These days, probably one of the biggest misconceptions is that all plant breeders are developing genetically modified varieties. They often bring up the example of seedless watermelon, and most people believe that that is a genetically modified trait, but in fact that comes from just using traditional plant breeding practices. Most of those varieties have been developed just by your common practice of making crosses and doing selections. Particularly in the horticulture breeding world, there are very few examples of varieties that people use and eat that are genetically modified.
Maybe the first misconception, I think, is that everything is genetically modified through genetic engineering. So I think this misconception is that we are inserting strange genes from somewhere else is not true in most crops, and it's certainly not true in beans. The science we know of plant breeding goes back to what we call the time of Mendel, of a little over 100 years ago. and he established the genetics of the segregation patterns of traits and so forth, and that formed the scientific basis for plant breeding.
The modern science of genetics, which aims to understand the process of inheritance, began with the work of Gregor Mendel in the mid-19th century. Even though he was unconscious of the physical rationale for heredity, Mendel certainly noticed that organisms inherit traits by way of discrete units of inheritance, which are now called genes. He developed his theory of inheritance from his experiments on the hybridization of green peas and is considered the founder of modern genetics.
People hear the word genetics and they get totally scared about it. It's like, no, that's too complicated. I don't want to deal with that. Period. I'm done with that. I wouldn't even consider this. And it's actually a lot of fun. I don't see it as a rocket science.
It's true. The basics of plant breeding are fairly natural and intuitive. The way plants have been changed on a genetic level through the process of selection is called domestication. And basic domestication began prehistorically with natural selection. For example, before wheat was domesticated, it would drop its kernels when ripe so as to reseed itself. But domesticated wheat keeps its kernels on the stalk and is therefore easier to harvest. This change took place when early growers discovered a mutation, or natural variation, of the wheat they'd formerly known. These stalks of wheat were beautiful, and more than that, easy to harvest. It was only natural that they'd pocket and save these seeds to plant again. This domesticated wheat now relies on growers for its own reproduction and dissemination.
Along with the scientific basis of plant breeding, we have the cultural aspects of plant breeding.
So when agriculture was having its beginnings in the Americas 10,000 years ago, pumpkin fruits, the little wild pumpkin fruits, were something that really got people's attention because they provided oils and energy in the seeds.
Farmers over time have gone to the field and looked at crops and chosen the ones that look the best for them, for their situation.
Little by little, we went from these little wild fruits to what we have here today, and that really has been the result of more or less 10,000 years, 10,000 generations of selection by farmers.
The roots of plant breeding go back to these old farmer-selected, we call them heirloom varieties, and these are the bases, yes, from where these modern varieties actually have come today.
This is maybe a little beyond what a farmer might have. Professional plant breeders have been able to make that final step, maybe going from something like this, which is already a quite edible fruit, ugly but edible, to this. So this step between here, which is just a farmer's selection, to here, is really the professional plant breeding work that we've seen in the last 100 years, let's say.
Modern plant breeders specialize in specific crops and organize programs tailored to improve these crops. Plant breeder Tim Porch has organized a project involving tepary beans. Unlike most crops, these beans are in the early stages of domestication, which means there's a lot of work left to do. But tepary beans are extremely drought-resistant and thrive in tough environments where it's normally very difficult for people to grow food. Tim is confident in tepary beans despite the challenges they present.
Tepary bean, it's Phaseolus acutefolius. And under these conditions where they haven't been watered for 3 weeks, you can see the difference between the response of common bean, which has a lot of wilting symptoms, and tepary, which shows very little symptoms at all. Teparies tend to have a very small seed size and aren't necessarily quite as palatable as common bean. So they don't have quite the allure of common bean in terms of cooking. But they've been used over centuries by Indian tribes in southern US and in Central America and Mexico. So they are very much palatable. I believe that this is a potentially future crop in areas that have a lot of arid conditions and severe drought stress. It comes from the Sonora deserts between Mexico and the US and has innate qualities that allow it to withstand high levels of drought stress. But it is also a legume, and so it has all the beneficial nutrients and protein that other legumes have, like common bean. But it's able to produce in very inhospitable climates.
Another example of modern plant breeding is the fight against UG99, a strain of stem rust that threatens 90% of the world's wheat. Stem rust is a fungus that can turn a field of wheat into crippled stems that produce hardly any grain. Stem rust has been a serious and ongoing problem. In 1999, a new race of stem rust surfaced. This race, discovered in Uganda, is called UG99. 90% of varieties used worldwide are vulnerable to UG99. Today, UG99 has mutated several times and is an even greater threat to global wheat production. But breeders are confident that they can use genetic variation to develop new varieties that will resist the deadly new races of stem rust. The original UG99 has already spread to Kenya, Ethiopia, Sudan, Yemen, and Iran. Research suggests that it will spread even further. Right now, breeders are at work developing plants with genetic resistance to this new strain. They will integrate resistance into varieties around the world as quickly as they can. Breeders have to be patient, tenacious, and willing to take a hard look at their own work. They've got to be fastidious note keepers and dedicated data crunchers. And as I'm sure you've realized by now, plant breeders spend most of their time in the field actually observing their plants.
It takes time to develop products. You have to be very diligent, be able to look at your material critically and throw it out.
Because it takes time to, go through all these hundreds, thousands of lines and try to figure out what is the one that is going to probably have some potential.
I think the other aspect that's probably underplayed or not as well recognized is an interest in plants, in plant improvement and working in the field.
If you don't like going to the field, you're not going to like plant breeding because a lot of our time is spent. Most of our time is spent in the field.
Do not get into plant breeding if you want to be inside all the time. You've got to know your plants, and they're grown in the field, not in your office.
This is my office, many cases, yeah.
Breeders spend so much time comparing traits and reviewing data that they develop a keen eye for spotting the best plants. If you're not used to looking at plants, it takes time to tune into the visual characteristics. But breeders are used to paying attention to these nuances. They directly observe the interaction of each plant's genotype with its environment. And just like the early growers, they too use it as a factor for making their selections.
We have 4,000 rows and we have to select them in a matter of a few days. So you have to have a visual, we call a breeder's eye, a perceived ideal plant type that you want to select for.
It takes years to develop that eye. But anything that's worth your while or investment takes time.
Though it's surprising to hear people describe plant breeding as both an art and a science, it also makes a lot of sense. Breeders have to find a way to balance creative problem solving with strategic planning. Plant breeders acquire an eye for spotting plants that data has proven are worth noticing.
Think of it as an art because you as a breeder, you have to have this eye. You have to figure out which valuable traits do you want to select, what do you want to put into your program, and how you're going to go about doing it.
You have to look at a lot of plants, but if you leave it only as a numbers game, you're missing out on a lot of opportunity to make great gains by visual selection. And that's the artistic part, that's the creative part, and I think each of us has both.
And part of the art is being able to see that difference with your eyes versus being able to measure it with a machine.
And so that's the perfect blend of art and science. It keeps you stimulated all the time, and I think it can get very boring if you're only one way or the other.
And so if you can combine those two approaches, then you tend to be more successful.
That's the exciting part, and where you're merging the science and the art, and challenge what you've been taught. So hopefully you have real discoveries.
Plant breeding is a career that allows people to immerse themselves in different aspects of the process, so that their work varies by the season and even by the day. They spend most of their time in the field with their plants, but they also take close notes on what they see and work very closely with data and statistical information back in the office.
I really enjoy plant breeding because each day can be quite different.
But I very rarely do the same thing one day to the next, and if I do, the next week will be different.
I love the fact from May to October I'm outside most of the time, out in the field. And then I enjoy the fact in the winter I get to sit down and look at the numbers to see how well I did the year before, making my selections and finding the winners.
I grew up on a farm, so I've always loved being in the field with plants. And it's always exciting planting out that seed and then waiting to see what those plants, what those children in the next generation are going to look like, and hoping that some of those will combine the traits that you're looking for.
For me, one of the most rewarding aspects of plant breeding is being able to generate something new, unique, that is valuable to sectors of society, farmers, consumers alike.
And you find things like in any area of science that are novel and unique, and can be very exciting.
The needs of the grower and consumer are never far from a breeder's mind. These needs are the reason to make new crosses and to find varieties that will perform better than the standard. And it's the vision of putting a new variety in the hands of growers and consumers around the world that defines the work of a plant breeder. At the end of the day, plant breeders know that their work really matters.